Steven, shall we start or? When you give me the okay, I will present Franco in Spanish. Los chicos vieron inglés, ¿no? ¿Todos inglés o en español? Estoy viendo a vos, no dijiste nada. ¿Cómo se mueven? Yo no entiendo. Después le ponemos ¿Cómo? Fran, como quieras. Si querés que quede en inglés, que quede en inglés, no hay problema. ¿No? Ya están dando, bueno. Buenas tardes a todos, bienvenidos a una tarde de charlas técnicas, ¿tá? No son las más aburridas, son las más divertidas, por lo menos para nosotros que somos los desarrolladores, ¿tá? Vamos a ir con las últimas charlas antes de mañana, a tener la presentación de la hackathon, en la cual todos los equipos que participaron de la hackathon van a presentar sus ideas y van a ser juzgados a ver quiénes van a ser los ganadores de la track. Así que nada, sin más preámbulos, les vengo a presentar a un blockchain engineer, especialista en Real World Assets, ex trabajador de AgroToken y actual empleado de SpaceDev, y además escritor técnico, apasionado por la criptografía. Él nos va a dar una presentación de CK in a nutshell, así que nada, démosle un aplauso a Franco.
Me quiero reventar subiendo. Muchas gracias. Hola, hola, ¿qué tal? ¿Se escucha bien? Bueno, I'm gonna give the presentation in English, okay? And I'll take it slow so that everybody can understand. Cool? Okay, so as Juan Manuel said, I'm a cryptography enthusiast. So I've been studying cryptography for about 2 years now. And one of the topics that I find very interesting is ZK proofs, right? And I feel like most people don't even know what they are. So today's talk is for you to, let's see if this works, yeah. It's for you to perhaps live with an intuition of what this is about and perhaps know some of the tools and important use cases that ZK proofs can be applied to, okay? Great, so let's go. Great, so let's start by dividing ZK proofs into two parts. So we have the zero part and then the knowledge proof, right? So let's first talk about knowledge proofs. What is a proof of knowledge, okay? A proof of knowledge is essentially a mechanism by which I can convince somebody that I know some information or some statement about that information, right? A very simple example is a password. And let's not think about all the hashing that goes, that happens in the background and the salting. Let's just think about the password. When I want to prove that I know a password, the easiest way to do that is to just provide the password, right? I just tell you a password and you compare with a database maybe, and then you know, I know the password, so I can prove my identity, sort of, right? It's kind of a very simple example, but you know, let's start slow. And maybe we can take it up a notch. Have you guys seen this structure? Do you know what it is? It's a Merkle tree, right? A Merkle tree is used in blockchain systems to try and, you know, compress and consolidate transactions in a block. And what we have here, just as a short refresher, let's see if this works. We have a set of data here. And what we do is we hash the data, and then we take it in pairs, concatenate them together, and then hash again. And we do this repeatedly until we reach a root. What this allows us to do is, it's kind of a fingerprint of the data, right? If we change any of these leaves here, then the root will completely change. Okay? So let's say I want to convince you that I know some element of this original data set. What can I do? Of course, I could provide all of these points of data to a verifier, right? And they could do the entire process and get to the root, and they would be able to compare roots and verify that the data is correct. But what we can do is do this. Instead of providing all of the original data, we can provide this partial, these hashes along the path to the root. And with this, we can, concatenate, calculate the hash, concatenate, calculate the hash, and get to the root. So it's a different way to prove that I know this point here, right? Okay, so this could work, but I ask you, is this zero knowledge? What do you think? Is it? Raise your hands if it is. You don't think so? Yeah, you're correct. So, yeah, it's not zero knowledge. And in particular, we have to reveal this point here, right? We have to give that to a verifier so that they can build the entire path leading to the root, correct? Okay, so it seems like we always need to provide some information, at least a minimal amount, but we need to do so. So I guess the question is, can we do better? Can we not reveal anything? And can we have this be sort of a statement like, I want to convince you that I know some data that leads to that root, but I don't want to give you the data. Can we do that? And here's a more tangible example. Perhaps I want to prove that I'm older than 21 years to go to a bar or something, but I don't want to tell you my age because I don't want you to think that I'm too old, right? So that could be another thing that I wanted to prove. And can we do that? Can we prove this without revealing our age? And the answer is yes, we can do so. And that's the zero knowledge part, okay? So what we have is, the way to do this is to hide the information behind a very hard problem, a very hard mathematical problem. And this perhaps sounds familiar, right? When we do a signature, a digital signature, what we have is, again, a problem that is very hard to reverse. So it's kind of a one-way thing. And this is kind of the same thing. We're going to be trying to provide a problem that's very hard to verify, but very easy to verify, but very, very hard to solve, right? And this is called, this type of problems are called NP-complete, but I don't want to bore you with the details. What I want to do is actually to play a game. So, you guys probably know this, right? This is the classic Where's Waldo game, right? So, can you find him? Can you find Waldo? Well, I know where he is, right? And I could tell you where he is, and then I would convince you that I know where he is, right? But let's say I want to do this in ZK style. I don't want to tell you where he is, but I want to convince you that I know where he is. Can we do that? Yes, we can. Here's a game we can do around that. We can grab a piece of cardboard, a very big one, and punch a hole through it. Since I know where Waldo is, I can place him under the cardboard and exactly on the hole, okay? And this is what you would be looking at. That's Waldo, right? Did I convince you? I know where he is, right? Did you learn anything from this? No. See if you can find him, right? And the moment I tell you where he is, which is around here, you cannot unsee it. It's there, you know. I leaked information, and I know, right? So this is the type of hard games or hard problems that we can hide information behind. The hard problem here is finding Waldo, and the fast solution or verification is the process that we did, right? And we can turn this into mathematical problems, but we won't do that today. That's just the idea and the intuition behind this. Okay, but you may ask, why? Why would I do that? I don't want to hide Waldo, I just want to say it's there, right? Well, of course, we have privacy problems. Waldo is not something that we want to keep private, that's fine. But for example, here are some examples of things that may be sensitive and may reveal some information that we don't want to reveal. Just to give you an example, account balances is something that is public on blockchains. Generally speaking, some blockchains have private balances. But the idea is that if we could keep that private in some way, hide it behind something like a hash, for example, and just prove that we have enough funds to perhaps do a transaction, that would be cool. We don't really have to expose ourselves and put a target on our backs by saying, hey, I got lots of money, and you get hacked and you get attacked and whatever. So yeah, some types of information are sensitive, so it's desirable to hide that information behind a hard problem, right? Okay, so that's one aspect of ZK proofs that we need to try to gain an intuition about. There's another one, and it's called interactivity. These processes tend to be interactive, okay? And this means that there's some back and forth between a prover and a verifier. The prover being the one that wants to convince a verifier about some statement. So again, let's play a game. You guys know the Rubik's Cube, right? So what can we do? Let's say I want to prove to you that I know how to solve a cube. Pretty easy, right? So a verifier would scramble that, give it to me, and I would take it, solve it, and give it back. Okay? But okay, the verifier could say, this guy, perhaps he has good memory. Perhaps he memorized the steps. Perhaps that's the way he figured out how to solve the puzzle, right? So maybe what he does is, okay, he takes back the cube, he turns around, he scrambles it, gives it back, and now I cannot know how to solve that from memory, correct? So I take it, and let's say for good measure, I also turn around, I solve it, I give it back to you, solved. Aha, you say, this guy, now I have more confidence that he knows, right? But for good measure, he does the same process again. He turns around, scrambles it, gives it back, solves it, good. Okay, after 3 times, I can say, yes, this guy knows how to solve the cube. Did I learn anything about how to solve the cube? No, not really, exactly. So this back and forth increases the likelihood of the prover knowing a statement or a solution or whatever information each time we do the process. And this is something that's natural of this type of process. And also, think about this. If the prover solves the cube partially and gives it to me, I will say, no, you don't know how to solve the cube, correct? So these 2 properties are very important. And actually, after seeing that, we can now give a more formal definition, okay? We have that a proof of knowledge is an interaction between a prover and a verifier in which a prover convinces a verifier that some statement is true. The statement is, I know how to solve the cube. The statement is, I am over 21. The statement is, I know where Waldo is, correct? And it has 2 properties, completeness and soundness. And actually, we know what it is because we gave an example now. That's the Rubik's Cube example that actually has those properties. Completeness means that if the statement is true, if I know how to solve the cube, I will always be able to convince you that I know how to solve the cube. That property is important because it means that the proof will always work if I'm being honest. And soundness is the other property we mentioned over the end, which is if I don't know how to solve the cube, then I will solve it partially for you and you will not be convinced that I know how to solve it, okay? Of course, these properties are more rigorous and we need to define them in mathematical terms, but we won't do that today because it would take lots of time. So, cool. But where's zero knowledge in this? We didn't say anything about zero knowledge. So zero knowledge is an extra property. Essentially, we say if we don't reveal any extra information other than this is true, then that's zero knowledge. This also has a more formal definition, but we won't go there today. We can talk about that later if you want, but it's pretty involved. Okay, so those are some of the basic ideas behind zero knowledge proofs, and with this we can gain some intuition on how they work. But now I want to tell you about some of the examples of zero knowledge proofs that we actually can use and exist. Okay, And this started with the first wave, as I say here, of protocols, of games, cryptographical games, that involve some particular statements, some particular facts that we want to prove are true. For instance, the Schnorr protocol was one of the first ones that emerged, and it proves knowledge of what's called a discrete logarithm. We don't need to care about that now, but it's a very particular thing. All of these also are very particular. For instance, range proofs allow us to prove that a number lies in some range between 0 and another number. And well, these other ones, you can check the links later, but yeah, they're also very particular things, right? And do you believe that this is a problem? The fact that we have very particular things or proving systems for particular problems? What do you think? Yes, why? Well, yeah, that's true. If one breaks, then we don't have many more things to do. That's right. But there's also the fact that this is inefficient in terms of implementation. Let's say none of these problems really solve the, let's say, the Where's Waldo problem, right? So if I wanted to create a proof system, a proving system for that, I would need to go to a cryptographer and say, hey, I want to prove this. Build something for me, right? And that's inefficient because we have to build that, we have to test that, we have to audit that, we have to battle test it. And that's not very efficient. So yeah, this is a problem. The first wave of zero knowledge proof were just very particular things. The question is, can we do better? And yes, we can. There's a new wave of more modern ZK proofs that basically separates the problem in two. We have a programmable part where we can define our statement, can define what we want to prove. And then we have another part which is like a framework or sort of a compiler, let's say. Yeah? We have a way to define our problem, and then this compiler thing takes our problem and generates a proof. So by doing that, we have flexibility. We can create any amount of proofs that we want, right? And there are two types of proving systems that exist, and you may have heard of this. These are CK snarks and CK starks. Snarks are proofs that are very, very small in size, very fast to verify. You may have heard them in the context of perhaps ZK rollups. So yeah, they're pretty cool. And we won't dive too deep into that. I just want you to, remember the name. And then you have ZK starks, which are quite different. They use this idea of what's called a state transition function. And they're used, generally speaking, to prove that we can get to a state from an initial state by following some, rules of state transition. But we don't want to reveal all the intermediate states, because that would perhaps be too heavy to parse, to use. So yeah, these are the two big names today. And again, they separate the problem into a part where we program the ZK proof and sort of a compiler that takes that and generates a proof, okay? And then there's the other thing. How do we represent these statements, these things that we want to prove? There are ways to do this, but one of the most common is talking about circuits. Circuits are this sort of, circuits, right? We use them in computers, or computers have them, right? But these are sort of circuits on steroids, we could say. Instead of using ones and zeros, they use many more numbers. And with that, we can start doing some arithmetic. And with arithmetic and maths, we can represent problems. Again, we won't get into the finer details of this, but I just want you to remember, we can build statements out of this seemingly simple constructions, okay? Okay, so what now? What we have here is a list of concepts and ideas that we need to dive into to really understand how this works. And I just wanted to create this slide for you to really see that this is a very deep topic. We really need to get into the math behind this and study a lot of things. We have Merkle trees here, we have hashing, this may ring a bell. Perhaps polynomials ring a bell. We just talked about arithmetic circuits. But like, what the hell are pairings? What the hell is a root of unity? It's you know, things. And in particular, one thing that I want to talk about is when we produce a signature, a digital signature, we tend to expect, you know, we produce a signature and send it to a verifier, and they just verify it, and that's that, right? But in the proving systems that we saw, we have this back and forth, and that's not very efficient as well. So could we turn that into a non-interactive thing where I just build a proof, send it, they verify it, and that's the end of it? And we can, because there's this Fiat-Shamir heuristic thing. Again, we won't really talk about that, but I just want you to know that we can. So we have lots of primitives here that in conjunction can allow us to build these zero-knowledge proofs, right? Okay, so now I just want to mention that there are lots of tools nowadays for us to build zero-knowledge proofs. Some of them, like Circum and Noir, are DSLs. So DSL is, well, it's a domain-specific language, right? And what this means is that this is kind of like a programming language that we can write, and it looks something like this. That's similar to Rust, if anybody has used Rust. And yeah, it actually, I mean, it really looks like we're programming something, right? We're building our system ourselves, and we don't really care what happens in the background. That's done for us. These are just some names for you to remember, and maybe after the talk you can investigate yourselves. Again, this is just to give a general idea, and there are more, of course. I don't want anybody to think that this is all that there is, right? And to finish things off, I just want to give you a couple examples of things or situations where we would want to apply ZK proofs. This is, again, just for you to have an idea of how to use them. There are many more applications. So let's start. First, I already talked about private balances on chain. So blockchains, again, generally speaking, are these public environments. So if I have a balance, it's public, right? So it would be nice if I could hide that, but still I could, make transactions with that. So let's say I encrypt a balance. Now, everybody that looks at my balance doesn't really understand what that means. So how does a blockchain know that I can do a transaction if that's hidden? Well, you can build a ZK proof, right? What you do is essentially you prove that you have enough balance, and also a couple more things like you're encrypting correctly to the receiver, that you know the value that you're sending. But essentially, the most important part is this one. You prove that you have enough balance, and that's it, right? This usually comes coupled with something that's called homomorphic encryption, but again, that's, anecdotic. So yeah, that's one application. Second, ZK rollups. We were just talking about that, right? ZK rollups are this, layer 2 blockchains that essentially they bundle transactions. Yeah, so they receive lots of transactions in a sequencer, what's called a sequencer, and they build this bundle in a ZK proof manner. And what they do is, hey, they tell the layer 1, hey, you have this state, initial state, this final state, and this bunch of transactions that I don't really want to tell you about because that would take lots of time for, validating that the state is correctly calculated. But I want to convince you that it's correctly calculated. So you just take that and you say, okay, that's good, this is a new state. So what we do is we build a ZK proof again. And yeah, what we prove is that the next state is correct, that the transactions are all valid, that there are no funky things. And after we do that, the layer 1 is going to say, yeah, okay, that's good, this is a new state. End of story. So yeah, ZK proofs are useful. And then last but not least, verifiable credentials and identity, which would be similar to the example of us being over 21. We want to prove things about our identity, but perhaps we don't want to reveal much of our identity. For example, let's say I want to access some credit, but I don't want to tell you how much I earn per month. So okay, I build a ZK proof. And I say, hey, I know I have this salary that I don't want to share, but I'll convince you that's enough for you to give me a credit. Cool, end of the story. I produce a proof, the verifier believes me, and they give me a credit. That's all. So yeah, these are some examples of things we can do with ZK proofs. Of course, this is not the end of the story. We can build many more statements. But yeah, just to give you an idea. And then, just to summarize things, we saw essentially what a ZK proof is, which is a system where two parties interact and a prover convinces a verifier about some statement. They do this by not leaking information, by hiding things behind a hard problem, right? And then this uses lots of funky maths that we won't talk about today. But yeah, by hiding things behind this hard problem, we can convince people about those statements. And yeah, we have lots of tools nowadays. These are not that new. You can check that yourselves after the talk. Yeah, the system is really flourishing. There are lots of things that you can do, lots of new things that are coming out all the time. And yeah, ZK technology is not something that's, just some stuff that's there and nobody cares about. It's a reality. It's really being used in production. It's being used in systems, and you should be aware of that, and you should try to start understanding what it's all about. Of course, there's much more to dive into, and I just want to, give you a rough idea of what this is, so you can leave and then continue studying yourself. I can say that it's kind of hard, but it's fun. So yeah, I invite you to keep looking at this technology. That's pretty cool. And yeah, that's the end of the presentation. That's me. This is my LinkedIn, I think. And then you have my socials here. I also write on Medium, so you can follow me if you want. Yeah, that's it.
Muchas gracias, Franco. ¿Preguntas? Me imaginé.
Bueno. Question. What is your favorite? What is your favorite DSL for CK? Mine, I've used a bit of Noir and a bit of Circum, but I feel like Circum is way too convoluted.
Yeah. Circum has the property that, or the characteristic, maybe you need to really understand what you're doing when you build a circuit. I didn't bring any examples, but you need to understand the math and the constraints you're working with. Noir is more of a, a friendlier thing for users or developers, right? So yeah, I think I need to dive more into Noir. I've been using Circum so far, but I think Noir is a better choice if you're a newcomer, and perhaps if you want to use Circum, you need to study a bit more. Yeah.
Any other question? ¿Preguntas, chicos?
Okay, maybe the reason that CK exists is for privacy as one of the main factors, right? But how to make people realize they need privacy as long as many don't care, and they should?
Yeah, that's a good question. I feel like that's more of a communication thing. We need to be able to transmit that, we need to take care of some of our users' data. And I know that users are not really aware of that, so it's our responsibility as developers to try and incorporate this into our systems and then communicate correctly. But first we need to build correctly as well.
¿Alguna otra pregunta? Bueno, entonces otro fuerte aplauso para Franco. Muchísimas gracias. Déjame el... Así que, como ya dijo Franco, sigámoslo en las redes. Escribe un artículo de Medium por semana, así que está bastante activo y si quieren entrar en temas de criptografía, es el lugar para ir. Ahora, cuando se actualice la presentación, vamos a pasar al próximo speaker, Gonzalo Bustos, también software engineer dentro del equipo de SpaceDev. Tiene varios años con desarrollo de smart contract y el día de hoy nos va a venir a hablar sobre el update de Pectra, que ya se presentó el otro día y ahora vamos a entrar un poco más a los detalles técnicos. Así que a ver si aparece la presentación, así le damos la entrada. No está descargada. Pero bueno, démosle un aplauso a Gonzalo y vamos a encontrar su presentación ahora.
Muchas gracias. Sí, esperemos un poquito a la presentación. Pero bueno, sé que hay habla hispana y habla angloparlante, por así decirlo, así que yo voy a encarar también la charla en inglés, pero de todas maneras podemos discutir las consultas en español. Así que nada, no se preocupen, vamos a resolver todas las dudas que tengan. A ver si podemos cargar la presentación. No sé, habrán escuchado mientras esperamos que se viene una nueva actualización de Ethereum. Así que nada, vamos a intentar de hablar hoy sobre una partecita, no toda la actualización, pues es un poco larga, grande, importante. Pero bueno, si la han escuchado está bueno. Creo que este tema es uno de los más importantes de la actualización. Así que nada, parece problemas técnicos. A ver, ahí parece que vamos.
Listo. Ya apareció la presentación.
Sí. Parece que ahí va cargando. Unos minutitos más y estamos. Okay, so hopefully you'll be able to understand me. If you don't, just tell me to slow down. But yeah, so let's try to start. So this talk is called the Gem of Spectra because of Ethereum's new update. But I want you to be able to infer when we finish this talk why it's called the Gem of Spectra, right? So let's just go over the agenda for today. I wanted to start talking a little bit about account abstraction and how we usually implement it nowadays. So there are lots of proposals to take care of the problems of account abstraction. But yeah, we're going to go through a few of the existing ones, and then we're going to try to build a new one, right? So build a new solution for account abstraction. Then we're going to try to iron out the details of the new solution that we built. And finally, just go over what we think the future may hold for this issue, right? So let's just move on and start strong here. So we know that externally owned accounts are the way for end users to interact with blockchain, right? And the EVM compatible networks. So let's just put an example forward so that we try to, so that we understand a little bit about the process, right? So a new user like Alice comes to the Web3 ecosystem, and she goes to a wallet provider of her choice and asks the wallet provider to give her a new wallet, right? So the wallet is going to be represented as a public key and a private key that we can see right here. And behind the scenes, the structure of Alice's externally owned account, which is basically the idea of the wallet being represented on-chain. So this externally owned account you can think of as what we call wallets. It's going to look something like this, right? So it's going to have a nonce, a balance, a code hash. Just forget about the hash part. It's just where we store the code. And also the storage root that, again, you can forget about the root. It's basically where we store all of the data for these accounts. So one thing that we need to know about is that all of Ethereum's accounts look like this, including smart contract accounts. So the main differentiator between externally owned accounts and smart contract accounts are that that externally owned accounts don't have any code associated to it and no storage, right? So now that we know a little bit about how externally owned accounts look, let's just try to understand what account abstraction is. So it's basically this idea of just abstracting ourselves away from the limitations that externally owned accounts have. So we know that externally owned accounts can trigger transactions, right? It's the way for us to just start transacting and basically just playing around with the Ethereum blockchain. But there are lots of limitations that come with it. So these are a few of the examples that I could come up with, but I'm sure that you can come up with a few more yourself. So basically, one of the things that I want to mention here is that we can only send one instruction, one transaction at a time, right? So there's no transaction batching. We would like to sort of have a way for us to send more instructions in one single transaction. We can see this in the, if you've ever worked with ERC20 tokens, then we know that sometimes if we need to use a few tokens from an externally owned account, we need to ask the owner of the externally owned account to sign the approval of the usage of those tokens, and then just move on to the transfer of the tokens. Then another example here is the requirement of funds. So externally owned accounts cannot interact with the blockchain if we don't have funds, right? It's sort of embedded in the nature of the blockchain, right? And that creates a lot of friction for onboarding new users. And it's something that it's quite interesting to see that it's a problem that we have had since the very beginning, right? So we would want to fix that. We would want a way to work around that. And yeah, the other two examples are sort of niche, but I still want to mention them. Juan Manuel gave a talk a few days back about, and he mentioned something about account recovery, where we cannot, if we lose our private key or our seed phrase, we cannot access any of the funds, any of the identity that we got from the externally owned account. So we would want to also have a protocol or a way to fix that, to basically just recover the account that we lost. And finally, just if you think of multi-sigs, we would want a way to have that be a native feature, right? We would want externally owned accounts to be able to have more complex processes or schemes for signatures. So basically, the idea is that they're not flexible enough. We want to make them more flexible. So the idea here is that we basically want to have the best of both worlds. We want to have the good things about the EOAs, which is they can trigger transactions, but we also want to add the things that it's missing, right? So we want, as it says here, the best of both worlds. So how do we usually go about this? How do we handle account abstraction today? Well, there are lots of different attempts at solving this. Some of them go just for a few of the features that we just mentioned, which is in this case with meta transactions and sponsoring. We have all of these EIPs, and I'm sure there are lots more that try to solve the idea of sponsoring transactions, right? Not having to pay for transactions. The problem that we mentioned when we mentioned that we don't want to have funds to interact and to play around with the blockchain. So the idea here for all of these EIPs is that we try to assign a piece of data, cryptographically of course, and then have someone else that has funds send it to the network. So this is just one way that we can solve sponsoring. But what if we wanted to go over maybe a bit more of a broader solution to account abstraction? Well, we can think of EIP 4337, which, as you can see, I'm not gonna just go over how it works, but as you can see, it's a pretty complex protocol, and I want to thank Alchemy for the illustration. But it's very complex. It has lots of entities and lots of contracts that need to be deployed. So we will want to make this simpler, right? And if we were thinking about making it simpler, we could also look at EIP 3074, which basically says, okay, just let's try to make the smart contract accounts take over an externally owned account. So just basically just have the code from a smart contract take over everything that we have on externally owned accounts, the balance, the nons, everything that we just went through. So what I want you to take away from this is that EIP 4337, one of the main implementations of against account abstraction, or against the account abstraction problems, is way too complex. And the other ones that we know of are too broad, right? Like they may have lots of problems down the line. So let's try to find an alternative. What if we wanted to find a new solution? Let's try to work on this together. And we know that the main objective here is to maybe transform in some way our externally owned account into a smart account, right? So a smart account would be the concept here of an account that can handle the best of both worlds. So can we use what we saw on the previous EIPs? Yes, of course. The idea here is to learn from our mistakes and from the good things that work. And one of the things that works is smart contracts. So smart contracts have the programmability that we're looking for. So we know we're somehow going to have to associate our externally owned account to a smart contract. But how do we do this, right? So let's just go over another resource we have at our disposal, which is the transaction envelope EIP, right? So this transaction envelope has, well, yeah, there is, the envelope. Basically says that we can introduce new types of transactions into the Ethereum ecosystem. So it's been great. We have used it a lot. We currently have 4 different types of transactions, starting from 0 to number 3. So if we wanted to let the blockchain know that we want to assign or associate code to our externally owned account, we could just use this, right? So let's just build a new transaction that, for just clarity's sake, let's just call it set code transaction, because we want to set code on our externally owned account. And we now know how to let the blockchain know what it is that we want to do, but we don't know how to do it yet. But let's think about what we need to do it, not how we want to do it. So what do we need in order to authorize the setting of code on our externally owned account? Well, as we said, we know that we're going to need a smart contract. So we're probably going to want the address of the smart contract that we're going to relate to. And another thing that we want, another feature that we want, is not requiring funds, right? So we want any externally owned account, either if it's one that has funds or not, we want it to be able to set it even if they don't have any. So that's another requirement. And then the last one is that we want only the externally owned account's owner to be able to set code and sort of make the transformation, right? So we can already smell like it sort of looks like we could implement it something like this, just having the idea of an authorization be an address and a signature that guarantees the cryptographic signature guarantees that only the externally owned account owner can sign it, and then that we don't require funds because we know that meta transactions already handle the signature of a piece of data and then send it by someone else. So basically, this could look pretty good. But what if we wanted to set code in multiple chains? Well, this is where we're getting way closer now. So the thing we could do is just add the chain ID parameter to the signature, and that would be basically it, right? So instead of having the authorization just be the signature, the address and the signature, we could do it with having the chain ID to know to which chain we want to associate the address with, and then of course the nonce basically just for replay protection. But this is the idea of just having multiple authorizations be linked to the envelope transaction in an authorization list. So you would have basically multiple signed pieces of these code, and then just add it to a list in the transaction that you want to send. So what happens here is that we haven't discussed how that would be done, right? So we know that we send a new transaction, and we know what data it needs, but we haven't gone over how we're going to associate an externally owned account to the smart contract. So one thing that I do want to mention here is that, like we said in the beginning, externally owned accounts cannot trigger transactions if they are associated directly to code. So that would make them smart contract accounts. And it's basically defined by this EIP that you can all go read. But basically, that's the difference. If you have code on your account, it's basically a smart account, smart contract account, and you cannot trigger transactions. So we need to work around this. And the way we can do that is just by saying, okay, let's just flag the code that we want to associate to our account. We're going to still be storing said code in our externally owned account and the code hash, but we want to flag it in some way that when we send it to the actual client nodes, they know that they're seeing some delegation and not necessarily a piece of code that actually says, okay, this is a smart contract. So it's going, I don't want to go too deep into this, but there's an EIP that specifies or says that it's not possible to deploy smart contracts that start with this prefix, right? So there's no smart contracts on chain and ever that can start with EF, right? So we can use that to say, okay, this is a delegation. This is a special kind of code. And then just for future proofing, we are going to use the number of the transaction that set the code to identify it in case we want to use this kind of structure in the future, right? So the result would look something like this, right? A delegation designator, which is basically just saying, okay, this is a pointer to a smart contract, and it's identified by the prefix of EF, the number 4, transaction in binary, and then the following bytes are just the smart contract account. So just to recap, a new user comes and asks the wallet provider to give him a private key and an address, which grants them access to an externally owned account. They sign an authorization that sort of looks like this. They just send it to a relayer, a bundler, whatever you want to call it. And that bundler has some gas to send the transaction on chain. And the node is going to associate the address to the code of the smart contract that we're pointing to. So basically, that's it. We have just set code on our externally owned account. Well, kind of. So there are lots of things that we need to talk about and a lot of details that are important here, but I just want to mention a few that I think provide a good idea of what's going on. So the thing that we just did is basically what is specified in the EIP 7702 that is coming in the Pectra upgrade of Ethereum. And yeah, let's just try to understand some use cases to maybe go over and see if we can learn something else. So what if for some reason I wanted to set my set code on my externally owned account, but I signed 2 different authorizations, right? So this one here and this one here. You can see chain ID is the same one, address is different, but the nonce is the same. And let's say that the signature are both signatures are valid, right? So in this case, the EIP specifies that just for simplicity's sake, we're just going to always pick the first one, right? So if you ever find this, that you have to deal with something like this, then you just know that the EIP specifies that you only need to grab the first one. Then a second scenario that I think it's confusing at times if you review the EIP is that We know that smart accounts or smart contracts handle storage in their own way, right? But now we're setting code and sort of transforming our externally owned account into a smart account. So where does the state or the data live now? Well, basically, it's just simple. It's what you would imagine. But I needed some confirmation when I read this. So I went deep and I discovered that it's actually just as simple as that. Since we discussed that all accounts in Ethereum look like this, then what the EIP specifies is that we're just going to start using the storage from the externally owned account, and it's not going to live somewhere else. So it's just like proxies, right? If you've ever dealt with upgradability and proxies, then it's just the same thing. So now let's just say I just sent the setcode transaction, but the account storage is not initialized. Well, this is kind of important. We don't use init code. So by not using init code, by not passing a piece of code that we run when we set the code into our externally owned account, then that basically means we don't have an initialization of storage, which it was done just to save gas. So that means that just as we do with proxies, we need to call an initialization method. So that's just another thing to keep in mind. And of course, when we implement this, we need to take care of front-running and replay attacks. And just the two last scenarios before we wrap up with this talk. What if I regret having transformed my externally owned account into a smart account? What if I just wanted to go back? Or what if I wanted to update it, upgrade the contract that we're pointing to? Well, that's easy. We can do both things. In order to revert your smart account into an externally owned account, you just pass the address 0 as the address you're pointing to in the authorization that we saw earlier. And that basically just turns it all back. The one thing that you need to take care of and to be careful about is that by setting this address to 0 does not clear the account storage. So if you ever go back to a smart account, you may find some storage clashing. But yeah, and if you wanted to just update it, it's the same thing. Instead of passing the address 0, you just sign the new authorization with the smart contract address that you wanted to update to. And finally, one thing that I find that is almost never mentioned, but I think it's quite important, is that how do we handle the nonce when we do this? So if you don't know, externally owned accounts increase the nonce of the account by 1 every time they send a new transaction. And smart contracts, smart contract accounts increase the nonce by every creation of a new contract that they trigger. So how do we handle this? Well, we handle it just by having both work at the same time. So what that would mean is that now for every transaction that we send, we may be increasing the nonce of the account by more than 1. So this could break, there are some use cases where it could break some implementations. So it's something that I thought was worth mentioning. So just to wrap up, what now? Well, this EIP, which is what we went through, is part of the latest Spectra update of Ethereum, and I'm sure you can all think of why I named the talk the Gem of Spectra. Well, basically because I think it's the most important EIP of the whole update. It's scheduled to release May 7th on mainnet, so nodes are actually currently being updated and preparing for May 7th. So that's it. Just get ready to use smart accounts. That's me, and I think that's my LinkedIn as well. So yeah, thank you so much.
¿Preguntas?
Hey, hello. Yeah.
Hey.
So essentially, this means that for just that every person that wants to use the new smart contracts after Pectra has to migrate to one of the new to a new wallet, to the wallet that has the smart ability. Therefore, there won't be something like upgrade in the background for the existing accounts that people already have.
I'm not sure I understood the question, but let me just say this. You can, starting May 7th, just choose whether you want to turn your account into a smart contract account, or actually a smart account, or or just keep it an externally owned account. You don't need to change it if you don't want to, and any existing externally owned account can have this done, so they can always transform into a smart account. The only thing that you need is just actually to have a smart contract you can delegate to. So that's the hard part of the adoption. You also want wallet providers to make it easy for you. But if you know how to code and you know how to send a new transaction, and let's say your wallet provider does not have this ability yet, then you can just do it by yourself. So be careful if you do it by yourself. There are lots of security issues with this if you are not careful enough. But yeah, you can basically do it to any account you want.
Yeah, but in that case, let's say I migrate to a smart account. I have an EOA,
Yeah.
and I want to give another person my address.
Yeah.
Which address will that person be required in order to deposit into my smart account? Will they use the contract's address, or they use my address?
So have you ever worked with proxies?
Yes.
So basically, you would just give the address that hosts the storage, right? So in this case, it would be the externally owned account's address, because you're delegating. So the delegation is just what happens with proxies, right? So you just use the code, but in the context of your externally owned account. So if you wanted someone else to start interacting with your new smart account, you would just use or give them the externally owned account's address, which is now a smart account.
Okay, so if I migrate, then I'm going to have to be using a new address.
No, not necessarily. So the idea here is that I want to get, well, basically this. So this, I'm sorry. Am I going forward or backwards? There we go. So this this code hash is the one that we saw. I don't know why I don't have one closer, but so it's this code hash. So if your externally owned account looks like this, then when you haven't, before you transform it, then this would just store like the hash of code 0, empty string. But once you transform it, what you're going to have is this. And that's enough to use your externally owned account. You don't need a new account. You don't need anything else. You just keep your same address, same everything, and this is going to be what's stored in your code hash. So now that tells everything else. So whenever someone sends a new transaction to your address, they're going to be executing the code of this address, but you keep the same address.
Oh, okay. That's what I was asking. So it will technically be transparent if I just move to the new version.
Yeah.
Great.
100%. Yeah.
Hey, great talk. So my question is around the multiplicity of authorizations, right?
Yeah.
So you mentioned that you will always use the first authorization that matches, the signature for a user. So I was wondering, what's the purpose of having multiple authorizations? Because here you have chain ID 1, chain ID 2, but my understanding is that you will always be on a single chain when you transact and have an authorization. So yeah, why would we want to have more authorizations there?
Yeah. So I skipped that in the talk because I didn't want it to take too long, but it's a good thing. Thanks for asking. I love that. So a few days ago on Juan Manuel's talk, someone asked what happens if we have multiple chains, right? So we know that our externally owned accounts live in every EVM compatible chain. So we basically want this, well, not this, not repetition, but chain ID 1, 2, and 3, because we want to make it as easy as possible to transform all of our accounts into a smart account. So, so whenever you connect to Ethereum and then to Polygon, you would want to keep the idea of a smart account. So let's say chain ID 1 is Ethereum and chain ID 2 is Polygon. You would want to sign both of these so that when you go use your externally owned account as a smart account on either chain, then they would be both set up. So, of course, the bundler or the relayer or whoever sends the transaction would have to send the transaction on each of the chains. But, of course, it's just the same transaction. I'm sorry, the same transaction, and they would just copy-paste it and send it on each chain. So that's the reason why, yeah.
Great, thank you.
Great.
Okay, let's give it another applause to Gonzalo.
Thanks.
Muchas gracias, Gonzalo. Gracias por resumirnos todos los EIP, porque creo que está difícil leer todos esos EIP, entenderlos, explicarlos y demás. Así que nada, muchísimas gracias por eso. Ahora, para finalizar lo que es esta jornada más técnica, viene Rodrigo Icaya, tesorero de la Cámara de Comercio Digital y Blockchain. ¿Lo dije bien? Sí, bien, perfecto. Vamos a ver si está la presentación, así no tenemos de nuevo el problema. Ahí está. Así que nada, démosle un aplauso a Rodrigo. Adelante, para atrás y luz.
Bueno, mi presentación va a ser en español. Por un tema de marca más que todo. Pero el objetivo de esta presentación, me voy a sentar, el objetivo de esta presentación es hablar un poquito acerca de lo que es la comunidad blockchain, cripto, web3 en Panamá. Cómo inició, qué retos han surgido a lo largo de los años, qué nos hemos encontrado, a qué nos estamos enfrentando en este momento. Así que, se fue, ya volvió. Así que voy a hacer una breve introducción. Esta foto que están viendo aquí es de un evento que se hizo hace 3 años, llamado el Blockchain Summit Latam, que vendría siendo una convención internacional con el objetivo en aquel momento de promover tecnologías disruptivas, emergentes, desde la Cámara de Comercio Digital y Blockchain, que es una asociación sin fines de lucro. Nos dedicamos a educar tanto a nivel privado como a nivel gubernamental. Y en esa foto, por ejemplo, este señor que ven en el centro, al lado de Yanis, de la única mujer del grupo, era el ministro consejero para la inversión privada. Porque el objetivo de ese evento específicamente era posicionar a Panamá como un país amigable con el entorno blockchain, criptos, web3, y nosotros desde la Cámara buscamos la manera de que eso ocurra en Panamá. Entonces, ¿cuál es la historia de la comunidad en Panamá? Realmente la historia surge a partir de personas como Eric Voorhees, no sé si lo conocen. Eric Voorhees. Eric Voorhees es, si no me equivoco, actualmente el CEO de Shapeshift. Él estuvo en Panamá. Acá en Panamá también había un pequeño grupo donde estaban muchos personajes del ecosistema, sobre todo de afuera. Llegan a Panamá entre el 2012-2013, comienzan a hablar acerca de Bitcoin, criptos en Panamá, a intercambiar información. No sé si Steven estaba en ese grupo. ¿No? comienzan a hablar acerca de Bitcoin, pero desde la perspectiva libertaria, la perspectiva tecnológica. Y comienza entonces ese grupo a expandirse, en Panamá específicamente, pero ellos ofrecían sus servicios desde Panamá hacia afuera, no para panameños. ¿Por qué? Porque ciertamente en Panamá, si estamos hablando de que en el 2025, hace 12 años después, todavía tenemos carencias en conocimiento en materia cripto y blockchain, ahora imagínate en el 2013. Estos chicos entonces ofrecían sus servicios a Panamá, pero no dejaron de conectar con panameños. Entonces, ellos comenzaron a expandir ese conocimiento cripto, pero sucede algo interesante. Específicamente yo no conocía de cripto sino hasta el año 2016. ¿Y cómo llegué a cripto? Llegué por algo llamado OneCoin. ¿Alguien escuchó de OneCoin alguna vez? Bien, les cuento. OneCoin era un proyecto que decía que iba a superar a Bitcoin, que iba a reemplazar a Bitcoin. Y fue promovido por muchas personas acá en Panamá así. Y a mí me invitan a una reunión de estas, donde hablaban de OneCoin, y recuerdo que esa era la narrativa. OneCoin va a ser el próximo Bitcoin, OneCoin va a desplazar a Bitcoin. Pero resulta que años después se descubre que OneCoin era un fraude. Pero muchos de nosotros habíamos puesto dinero en OneCoin. Esto me lleva a un siguiente plano. Yo tengo diferentes backgrounds, tanto en perfil comercial como en perfil académico, por la formación científica que tengo desde la universidad, en mi rubro. Y algo que yo recuerdo que yo me decía, todo lo que a ti te dicen debe estar sustentado en ciencia. Entonces comenzaron a hablar de criptomonedas, comenzaron a hablar de OneCoin y comenzaron a hablar de que OneCoin iba a reemplazar a Bitcoin. Y lo que yo hice fue ver si existía algo relacionado con criptos en el 2016, pero desde una perspectiva científica, desde una perspectiva académica. Y encuentro la Universidad de Nicosia. La Universidad de Nicosia, desde el 2013, Nicosia está en Chipre, en un punto medio por Europa. La Universidad de Nicosia desde el 2013 ya impartía una maestría científica en monedas digitales. Y para tú estudiar esa maestría, recuerdo que tú tenías que pasar un primer módulo, que era un curso masivo online. Y si pasabas ese primer módulo, tenías la oportunidad de estudiar la maestría completa. Entonces, cuando yo me inscribí en el módulo, porque era gratuito, en el primer módulo, sí, porque era gratuito, comencé a entender realmente de qué era Bitcoin. Porque la universidad te lo explicaba desde la perspectiva de las ciencias de la computación, desde la ingeniería en sistemas, desde sistemas computacionales, desde la perspectiva del código, y adicional mezclaba innovación, mezclaba desarrollo de negocios, mezclaba disrupción y cómo Bitcoin como tecnología tenía un impacto en el sistema financiero y en el sistema económico. Y allí fue cuando realmente aprendí sobre Bitcoin. Recuerdo que casi 3 meses, 4 meses en ese primer módulo. Las clases eran los martes y los jueves. ¿Alguien conoce a Andreas Antonopoulos? ¿Andreas? El autor de Mastering Bitcoin. Andreas era uno de los profesores de ese módulo. Resulta que cuando comencé yo no soy de background de sistemas, yo soy comunicador empresarial. Cuando comencé a estudiar Introducción a Monedas Digitales, que era el nombre del primer módulo, donde te enseñaban código. Así que te imaginas el shock mental que yo tuve desde la perspectiva de la comunicación empresarial hacia temas relacionados con sistemas y programación y desarrollo. Pero me gustó. Me llamó la atención, me dio la perspectiva que necesitaba sobre el tema cripto. Y desde allí terminé el módulo, afortunadamente lo pasé con 87 y me dio la oportunidad de avanzar, pero no avancé en ese momento. Lo que hice fue que agarré ese conocimiento que adquirí durante ese periodo de tiempo estudiando con la Universidad de Nicosia y dije, me voy yo solo a decirle a la gente lo que es Bitcoin y lo que no es Bitcoin, y que OneCoin era un fraude. Y desde entonces, 2016, finales del 2016, inicios del 2017, iniciamos el proceso de hacer meetups en un restaurante en Avenida Balboa. Y ese meetup, lo que yo sin quererlo, más que todo era con la narrativa, con la esencia de querer educar a las personas o de que las personas tuvieran información basada en ciencia, en este caso ciencias de la computación. Recuerdo que comenzaron a llegar personas y comenzaron a llegar más personas y esos meetups, recuerdo que comenzaron a consolidar a la primera generación que estaba en Panamá desde el 2013 con una nueva generación que comenzó a formarse a partir del 2017. De allí surgieron algunas iniciativas, ahora me voy a pasar a esta. Esta es como la ruta que iniciamos desde el 2017. Desde allí, desde aquellos meetups, nació una iniciativa llamada Panama Blockchain Embassy, que era un sitio, un showroom, una especie de coworking, showroom, coffee. Creo que, Roberto, tú llegaste a ir allí, al Panama Blockchain Embassy, es la imagen de abajo. Y en ese lugar comenzamos a hacer los meetups, más técnicos, habían personajes que hacían talleres y demás, pero siempre con el objetivo de darle a la gente información basada en lo que ya habíamos aprendido con la Universidad de Nicosia. Después del Panama Blockchain Embassy en 2018 se crea una asociación, que es la asociación que yo actualmente represento, que es la Cámara de Comercio Digital y Blockchain, que trabaja con el sector privado y con el sector gubernamental, pero nos hemos inclinado un poquito más con el sector gubernamental porque hemos identificado que hay mucha falta de conocimiento en materia técnica, en materia financiera y en materia económica. Y son quienes ejecutan leyes, pero también trabajamos con los de la Asamblea Nacional, que son los que proponen leyes. Y yo siempre he dicho, la Asamblea Nacional es un punto donde fluye el conocimiento, porque así como nosotros conocemos sobre un tema, hay mucha gente que conoce sobre otros temas y tenemos que debatir ese conocimiento. Entonces, hemos hecho diversas capacitaciones con asamblea, con representantes de gobierno central, con empresa privada, pero en este momento nuestro foco está en trabajar con el funcionario, con el que regula, para que regule bien en caso de que quiera regular. Creo que en la mañana estuvimos hablando un poquito de regulación y las necesidades que hay, pero siempre mirando, 1, al desarrollo del país, 2, al desarrollo del ecosistema y 3, al desarrollo del individuo. Siempre mirando hacia esos 3 pilares. Porque si nos vamos solamente a desarrollo país, ocurre algo que está sucediendo en la Unión Europea, donde sus políticas se están volviendo restrictivas en contra de la tecnología. Y no están viendo el desarrollo del ecosistema tecnológico como un beneficio para el desarrollo del territorio. Dicho esto, posteriormente mi equipo y yo nos retiramos del Panama Blockchain Embassy y decidimos abrir un concepto, trabajar en un concepto llamado The Blockchain Space, que actualmente es un espacio de coworking. Y desde allí, desde esas iniciativas, surgieron otras, llamada por ejemplo Panama Glass, que fue la primera conferencia blockchain que se hizo en Panamá, en 2018. Y Panama Glass estaba más orientado en transparencia gubernamental, aplicar la tecnología blockchain a procesos gubernamentales. Luego se hizo Panam Chain, de hecho en Panam Chain, este es Andreas Antonopoulos para el que no lo conoce. Andreas vino a Panamá para ese evento. Y fue básicamente un concepto así, como hemos visto hoy, paneles, talleres, exposiciones, y él era el expositor principal. Pero siempre desde esa perspectiva de computación, lo que él maneja. Si ustedes no han leído Master in Bitcoin, En este momento está desarrollando su tercer volumen. Master in Bitcoin 1, Master in Bitcoin 2, en este momento está escribiendo Master in Bitcoin 3 y además, si no me equivoco, escribió Master in Ethereum. Entonces, Andreas es tecnólogo, tiene mucho contenido al respecto desde los inicios de la tecnología y es una persona con la cual tú puedes aprender incluso conversando. Pasamos luego al 2019, America's Blockchain Summit, luego en 2022, que es el Blockchain Summit Latam, que era la primera imagen que les mostré al inicio de la presentación. Durante estos años hemos identificado varios aspectos. Creo que en este momento vendría siendo uno de los puntos clave para nosotros en Panamá, porque a pesar de ser un país relativamente pequeño en materia de ecosistema Crypto Blockchain Web 3, según Chainalysis, para el 2021 y 2022, en Panamá se movieron 6.75 mil millones de dólares en transacciones con criptos. Pero, según Global Ledger, que es otra consultora, competencia de Chainalysis, entre 2021 y 2024, en el ranking global de los top 10 exchanges del mundo, se ha movido 8.5 mil millones de dólares. Solamente Global Ledger, a diferencia de Chainalysis, lo que hizo fue que solamente consiguió o se enfocó en los 10 primeros exchanges. Chainalysis hizo un estudio un poco más profundo. Entonces estos datos a nosotros nos sirven para tomar decisiones con base en cómo se quiere desarrollar el ecosistema local, qué negocios pueden impactar en Panamá y también nos obliga a nosotros como asociación a querer desarrollar otros estudios basados en el comportamiento de los usuarios, específicamente cripto, en Panamá para determinar, por ejemplo, aquí hablamos de que el alcalde ayer o antes de ayer firmó un convenio con Tower Bank para aceptar pagos con criptos. Pero esto nos lleva a nosotros a querer estudiar cuál es el comportamiento de los usuarios criptos en Panamá. Si están dispuestos a pagar impuestos con cripto, uno, o si el usuario extranjero que viene a Panamá prefiere pagar con criptos para evitarse comisiones por pagos con tarjetas y demás. Entonces hay que estudiar un poquito el comportamiento de los usuarios para tener una noción que incluso nos permita utilizar con base en iniciativas legislativas. Dicho esto, según Chainalysis, para el 2024 hay un uso intensivo de criptomonedas, específicamente para remesas, inversión y ahorro. En esta imagen podemos ver uno de los hackathons. Este hackathon, si mal no recuerdo, se realizó en 2018 con Panam Chain. Microsoft era el promotor de ese hackathon. Y esto nos permite identificar cuáles son los perfiles de los usuarios en Panamá. Por ejemplo, acá, jóvenes, adultos conectados con la tecnología, eso es clave. Mayormente jóvenes son los que usan criptos. Jóvenes de 35 años, quizás 36, 37 o de 40 hacia abajo, están más familiarizados con las criptos. Las criptos les ha permitido a estos jóvenes, indistintamente de la profesión que están estudiando, aprender sobre temas de educación financiera de manera indirecta, de manera informal, por su constante práctica en el día a día. Pero identificamos nuevamente que los principales usos son inversión, ahorro, e-commerce y remesas. ¿Y por qué traigo a colación esta parte de la presentación? Porque hoy, en términos regulatorios, muchos abogados se inclinan por querer regular criptoactivos en Panamá según los estándares GAFI, bajo las definiciones de la GAFI, donde determinan un nombre que es activos virtuales, pero activos virtuales pueden ser muchas cosas. Y lo que realmente le da la identidad a las criptos no es un estándar internacional, no es una ley, sino el uso que le da la persona. Y eso es algo que nosotros desde la Cámara defendemos mucho, porque, por ejemplo, lo que acaba de hacer el alcalde Mayer gira completamente la definición de Gafi. Lo está utilizando como una forma de pago. Pero cuando nosotros estudiamos formas de pago, hay una lista de formas de pago que se definen como instrumentos financieros. ¿Y cuáles son esos instrumentos financieros? Dinero en efectivo, pagares, cheques. Entonces, al hablar de criptos, digamos, qué forma o qué nombre o qué tratamiento van a recibir de acuerdo con ese uso que se le dé? Dicho esto, retos y oportunidades que nosotros encontramos en empresas de rubro tradicional actualmente con comunidades. Hice todo el background para entrar al punto de comunidades porque actualmente mi equipo y yo, nosotros somos 3, lideramos una de las comunidades quizás un poco más grandes en Panamá llamada The Blockchain Space, igual que el espacio de coworking. Y lo que hemos visto con estas comunidades y a partir del comportamiento de ellas es, primero, que son usuarios, y si alguno está aquí me puede decir fácilmente, son usuarios que no les gusta que le vendan un producto, sino que les gusta vivir una experiencia para tomar una decisión. Y eso es producto del uso que tienen ellos con las criptos. Esto nos lleva a nosotros a identificar que las empresas de rubro tradicional que quieren involucrarse en el ámbito cripto tienen oportunidades como, por ejemplo, desarrollo o identificación de nuevos productos y servicios, cercanía y promoción espontánea local o internacional. Y esto de cercanía y promoción espontánea significa que hay una tendencia global a que, por ejemplo, si un comercio acepta criptos, viene alguien de otro país y graba un video y dice, pagué en tal lugar con criptos, y le da promoción instantánea, promoción gratuita. Y otra de las oportunidades es que una vez que se detecten necesidades, entonces ese usuario cripto pueda ser convertido en un potencial cliente. ¿Cuál es el caso más reciente que ustedes pueden observar en este contexto? Tower Bank. Tower Bank comenzó trabajando con la comunidad y ahora está lanzando algún producto o un servicio enfocado hacia esa comunidad. Sin embargo, también las empresas de rubro tradicionales tienen retos. Primero, que muchas veces no se entiende la esencia nativa de lo que es trabajar con criptos o ser usuario cripto o promover Bitcoin o promover Ethereum. Pero hay una esencia más libertaria. No tanto a ser un consumidor pasivo, sino a ser un consumidor activo, donde el consumidor te dice como empresa, yo quiero esto y si tú no me lo das, yo me voy. Otro de los retos es la comprensión del intercambio de información en cuanto a temas de comunicación. ¿Esto qué significa? En el ámbito bancario hay muchos términos, quizás técnicos desde la perspectiva bancaria, pero cuando tú eres usuario cripto y tú te sientas con un oficial de banca y tú le dices mi billetera digital o mi wallet o la dirección de billetera o el contrato inteligente, o si hablas en términos de staking, de mining, el usuario, el proveedor, en este caso el oficial de cuenta, no te entiende de lo que le estás comentando. Entonces este es uno de los retos que tienen las empresas tradicionales, sobre todo el sector financiero, aprender el lenguaje que nosotros manejamos para poder tener comunicación fluida. Otro de los retos es el mantenimiento constante de innovación o novedades, y esto parte de la esencia de lo que es el código. Siempre se dice que el código un día funciona y al día siguiente no funciona. Entonces, esto implica que las empresas tengan que estar innovando constantemente para mantener precisamente a la comunidad interesada en lo que ellos están haciendo y hacerlos partícipe, que es el siguiente punto, involucramiento de miembros en procesos operativos basados en I+D. I+D es investigación y desarrollo. Y este punto I+D es donde entra mucho el perfil técnico del ecosistema, aquellos que son programadores y desarrolladores. ¿Por qué? Porque yo, desde una perspectiva cripto, puedo decir que toda empresa necesita un departamento de investigación y desarrollo para descubrir nuevos productos y servicios. Llámese protocolos, llámese formas de procesar información, etc. Y por último, dentro de los retos es la capacitación de personal interno para relacionarse con los miembros de la comunidad. Bien, en cuanto a temas de posicionamientos de marca, tiene que ver mucho con el punto anterior. Las comunidades, viéndolo desde la perspectiva blockchain space, nosotros hemos trabajado con algunas empresas y siempre la comunidad se ha mantenido hablando sobre el tema y eso genera un respaldo, una validación y una confianza desde la perspectiva comercial y social. Cuando se realizan eventos o actividades donde la comunidad se involucra y además la empresa adopta esa comunidad para realizar alguna acción específica, vemos que se expande la marca. Y esto sucedió incluso con Towerbank y los pongo de ejemplo porque es el único banco que lo ha hecho y al que le tocó aprender digamos, en el recorrido. Recuerdo que cuando Towerbank anunció en 2022 que ellos iban a ser un banco crypto friendly y Cristóbal Pereira, un chileno, lo publicó en sus redes. Recuerdo que al día siguiente las redes fueron un boom y la gente comenzó a llamar al banco porque querían abrir la cuenta crypto friendly. Y Towerbank no se daba abasto para atender la demanda que se le vino encima en ese momento. Entonces, ese posicionamiento se logró de manera internacional solamente por el tweet de Chris. Y comenzaron los medios internacionales a publicar al respecto. Entonces, ¿a qué me lleva esto? Nosotros como comunidad, ya sean programadores, desarrolladores o comerciales o personas que están dentro de una comunidad específica, tienen el poder de lanzar a una empresa o de tumbarla. Porque están tan inmersos dentro del desarrollo del ecosistema que entonces hace que esa comunidad genere confianza y validación de a quién respalda la comunidad. Y esto me ha llevado también a un siguiente punto que es desarrollo de estrategias DAOs y NFTs. Una de las comunidades más recientes es Panama DAO. ¿Han escuchado Panama DAO? Panama DAO es una comunidad, es una DAO específicamente, enfocada en public goods, en apoyar proyectos que tengan un impacto de bien común. Por ejemplo, alguno de los ejercicios que ha hecho Panama DAO específicamente es, por ejemplo, el año pasado, si recuerdo bien, ellos pudieron hacer una renovación del piso de un colegio. ¿Y cómo lo hicieron? A través de la votación democrática que hay en las DAOs específicamente. Alguien subió un proyecto dentro de la DAO y las personas comenzaron a aprobar ese proyecto hasta que se logra, digamos, el quórum y dicho proyecto entonces es ejecutado. Y así han desarrollado otros proyectos y, aclaro, Panama DAO está en Ethereum en este momento. Y esta es la manera en cómo las comunidades pueden orientarse para desarrollar proyectos que impacten e incluso mejoren la perspectiva de quienes están afuera, de quienes son no coiners, en cómo realmente se utiliza la tecnología para beneficio de nuestro entorno. Nosotros, desde la perspectiva de la Cámara, tenemos, digamos, algunos puntos todavía por alcanzar dentro de los próximos meses. Y como les mencionaba hace un rato, las investigaciones que han hecho las consultoras internacionales nos ha llevado a nosotros a tener la necesidad de estudiar el mercado local, el comportamiento que tienen las personas en relación con las criptos. Y es uno de los estudios de mercado de comportamiento que queremos hacer, de comportamiento de usuarios. ¿Qué es lo que sucede? ¿Cómo la usan? ¿Cuál es cuál es el propósito del que usen criptos? Lo siguiente es que actualmente estamos en una mesa de trabajo para la elaboración de un proyecto regulatorio. Nosotros estamos invitando a técnicos, no técnicos, abogados, no abogados a participar de esa mesa porque se necesita el insumo de todos para crear un marco regulatorio sólido que sea beneficioso para el ecosistema, para el país y para el individuo. Y también tenemos una iniciativa que es lanzar The Block, que sería un evento bandera de la Cámara, en donde la idea es retomar ese esfuerzo conjunto con las comunidades, con las organizaciones locales, criptos, blockchain, Web3, para entonces posicionar y retomar ese posicionamiento como Panama Hub, no digital, sino blockchain Web3. Así que estas son mis conclusiones. Nos hemos venido destacando, tenemos un gran reto todavía por desarrollar o por alcanzar, superar. Las comunidades son vitales, sobre todo aquellos que son programadores, desarrolladores, quienes están acá. Y pues tenemos un reto en cuanto a regulación, educación, para mantenernos sostenibles como país y como ecosistema. Así que, gracias. ¿Preguntas?
Rodrigo, ¿cómo andás? Muchas gracias. Yo tengo una pregunta, ya que estuviste hablando mucho de iniciativas y me parece o sea, me gustaría adentrar un poco más sobre colaboración con universidades, ya que me parece que nada, es una de las iniciativas que van a tener y va a ser el futuro, la gente más dispuesta o predispuesta a entrar sobre esto, entender un poco cuál es la situación de las universidades con respecto a esta tecnología, no únicamente con la de sistemas, y cómo de la Cámara pueden estar ayudando a eso.
Bueno, te comento que justamente hace un rato le comentaba a Steven que hace 2 días una de las chicas del ecosistema, no sé si conocen a Patricia Carrillo. Patricia me llama y me dice, Rodrigo, mira, los profesores de la Facultad de Sistemas de la UTP quieren hacer eventos con estudiantes, eventos con empresarios, eventos con miembros del ecosistema para generar networking, para hacer presentaciones, para que ellos vayan desarrollándose y que cuando salgan de la universidad ya no vayan perdidos, sino que ya tengan contactos, lugares donde poder desarrollarse. Irónicamente, en la Universidad Tecnológica de Panamá hay una tesis sobre Ethereum que se desarrolló hace años, en 2019, pero ha quedado allí, no se le ha dado mayor, digamos, como relevancia. Y a pesar de que yo también soy egresado de la UTP, ahora yo sí estoy presionando un poco más porque lo que estamos buscando y sobre todo trabajando desde la perspectiva de blockchain aplicado a la trazabilidad de alimentos, dentro de mi facultad que tiene la carrera de Ingeniería en Alimento, estoy trabajando con ellos para realizar un hackathon orientado al desarrollo de blockchain aplicado a la gestión de alimentos, ya sea para trazabilidad de productos o ellos me comentaron que están interesados en trabajar a nivel de gestión de residuos alimentarios. Entonces allí hay una oportunidad. Ayer tuve la oportunidad de conversar con un profesor de la carrera de Ingeniería Industrial y él me dice, Rodrigo, ¿cuándo vamos con los estudiantes de Industrial para que les cuentes sobre cómo usar su dinero con criptos? Y yo le digo, yo no hablo de ese tema, a mí no me gusta el trading, yo no soy trader. Pero sí podemos hablar de cuáles son las opciones digamos, que pueden aplicar ellos con la tecnología hacia sus procesos industriales, logísticos, multimodales, etcétera. Eso es un campo de estudio. Actualmente nosotros también tenemos convenio con la Universidad del Istmo. Lo firmamos este año, a mediados del año pasado, y hemos trabajado con el decano de la Facultad de Sistemas. En mayo vamos a tener una sesión con estudiantes de Derecho específicamente, y la UDI está muy también abierta a colaborar con digamos, con el desarrollo del ecosistema. De hecho, desde la perspectiva también de ciberseguridad, que ellos tienen una carrera específicamente en ciberseguridad. Así que nosotros en este momento, tanto con la UTP como con la UDI, ya tenemos una relación y el que quiera trabajar nada más me dice, me llama y me dice, Rodrigo, quiero hacer algo, yo gestiono con los profesores y vamos trabajando. Dicho esto, tanto con la UDI como con la UTP, más con la UDI, porque ya me lo han dicho de manera muy abierta, nosotros no solamente trabajamos a nivel de provincia de Panamá, sino que podemos trabajar a nivel de provincias, a nivel de provincias centrales, donde ellos tienen sus sedes. Así que sí hay un trabajo que se está haciendo con universidades, todavía falta mucho, sobre todo porque está la apertura, pero cuando son universidades sabemos que hay un tema de educación formal donde se regula el pensum académico, donde tiene que cumplir con ciertos criterios incluso para desarrollar programas académicos. Y aunque hemos estado conversando incluso con la UDI para desarrollar algún tipo de diplomado específicamente sobre blockchain, todavía esa parte hay que trabajarlo un poquito más. Pero hay apertura y a través de la cámara se puede hacer también.
Hey, oye, ¿cuál es tu opinión sobre la propuesta actual de la ley, la ley cripto que se está promoviendo para este nuevo periodo?
Gracias. Ok. No. Bien. Yo fui uno de los que reaccionó en contra, muy abiertamente. Y a pesar de que tengo el alcance quizás y que ya he trabajado con asesores de la asamblea en temas cripto, yo sí no soy muy político en ese sentido, así que yo sí reacciono inmediatamente. Yo digo, eso va en contra del ecosistema. ¿Por qué digo va en contra del ecosistema? A pesar de que es una iniciativa que está quizás bien estructurada en ciertos puntos, pero cuando se regula, tú no puedes regular desde lo general, sino que tienes que regular desde lo específico. ¿Por qué digo esto? Y no aplica para todo, porque hay cosas que se pueden regular de manera general. Pero lo que vi en este proyecto regulatorio es que busca regular a nivel de empresas como quizás Binance o empresas grandes, cuyo objetivo es quizás traerlas a Panamá. Pero ¿qué pasa? Que no deja margen para que los exchanges locales se expandan, crezcan, se desarrollen. Entonces eso hace que por querer regular empresas grandes que ya existen, matas entonces a las pequeñas que tenemos localmente. Por ejemplo, cuando te piden una licencia y $500,000, o sea, un pequeño no te va a un pequeño no lo va a hacer, quizás un banco sí. Pero entonces se tiene que regular en función no solamente del uso, como mencionaba hace un rato, sino del perfil que entraría en ese marco regulatorio. Entonces ya desde allí yo digo, eso no puede pasar. No puede pasar porque matas. Y mira, fue pensado para empresas grandes, pero es el desconocimiento de cómo funciona el ecosistema local. Entonces allí hay un reto que trabajar. Sin embargo, tengo que decirlo y tengo que aceptarlo, el diputado proponente ha tenido la humildad y ha dicho, por favor, yo quiero conversar con ustedes, todo eso se puede cambiar. Justamente hoy con la presidenta de la Cámara hubo esa conversación, todo eso se puede cambiar, quisiera su feedback, es decir, están abiertos a, y nosotros también estamos dispuestos a. Y no nosotros, porque al final nosotros como asociación podemos representar o más bien a las personas con quienes trabajamos, pero hay muchos actores del ecosistema que no forman parte de la asociación y no los podemos representar directamente a ellos, pero sí los invitamos a que formen parte de estas iniciativas para que no se queden solamente criticando, no, eso no va, no, involúcrese, brinde su argumento, diga qué le parece, qué no le parece y avancemos, porque Panamá sí necesita una ley. Pero ¿por qué necesitamos una ley? Ahorita tenemos una situación, se quiere regular por imposición internacional, porque Gafi el próximo año nos va a evaluar y si no seguimos las recomendaciones que la GAFI da, entonces nos meten en una lista. Entonces, desde una perspectiva tradicional de gobierno, comienzan los funcionarios a decir, bueno, yo tengo que regular aunque yo no lo conozco. Es más, dentro de las sesiones que yo he hecho con gobierno, muchos de ellos me dicen al final de una capacitación, Rodrigo, yo tenía otra perspectiva de esto, no como tú lo has presentado. Entonces eso cambia inmediatamente la forma de pensar y te da otras nociones. Pero están sucediendo muchas cosas en este momento. Lo del alcalde creo que es como el punto bandera, porque le da otro tratamiento distinto a lo que quizás se venía hablando normalmente en cuanto a temas regulatorios. Así que hay muchas cosas sucediendo, pero cuando vamos a llevarlo al papel, tenemos que ser lo suficientemente abiertos, pero lo suficientemente específicos y detallados para cada cosa, según el perfil, el uso y lo que vaya a ocurrir. Así que mi perspectiva, o más bien mi postura es negativa respecto a la forma como está redactada la ley, pero no significa que no podamos trabajar en algo que sí realmente beneficie al ecosistema.
Thank you, Rodrigo. Thank you, everyone, for bearing with us for an amazing week so far. Our friends from Space Dev, Gonzalo, Franco, Juan Manuel from UTP. I think we've had an amazing week of learning, collaboration, inspiration, some walking through our past and how we got here. Couple of housekeeping things. There's a DJ out there. We have still lots of kindness from Heineken. There is an event tonight over at the convention center. There's a bit of a party. I think everyone's invited to go. There's also a Binance VIP event at Ahazar, which is a great venue at the U. And I think there's a party tomorrow night at Embassy, which is nearby. It's an off-chain social event. And tomorrow we have half a day of hackathon finals. And we'll have, I think, 1 or 2 talks. I want to thank everyone for participating in ETH Canal. I think this is, as Rodrigo highlighted for us, a transition. And we got here because of all the things that have been happening. And you know, Juan Manuel, you guys have been super great supporters. You know, I think collaboration between us small countries is something that we need to continue and continue in a big way. Thanks, you guys. Thank you, La Manzana, Edwards. Thank you for all the support. We have one more day, and our hope is that we can make La Manzana and Casco Viejo a logical place for expats and locals to build from. I think it's a great neighborhood. I love the kind of like open campus feel. And thank you, everyone.